Good afternoon, Year 6. It's Mr. Tuckwell again with our second lesson of the week, all around position and movement. But to start with, as always, we're going to have a warm-up, and this week it's all about fractions. Today we've got multiplication of fractions. We have a quarter multiplied by 4/5. We can say that instead of multiply or times, we can use the word of here. So it could be said that it's a quarter of 4/5, which is another way of looking at it. And when we did it visually in the winter term, that's what we would have said. But today we're going to look at the system base that we use to solve it, which is to multiply the numerators together, 1 and 4, and the denominators together to get the answer. So very simply, 1 multiplied by 4 equals 4, and then 4 multiplied by 5 equals 20. Now, when we're doing this, you sometimes have a question which says the answer has to be in its simplest form. And that means we look to see if there are any numbers that go into 4 and 20 without leaving a remainder. And what we're ideally looking for is the highest common factor that goes into both 4 and 20. 2 is a factor of 4 and 20, but it isn't the highest one. 4 is the highest factor, because 4 goes into 4 one times. So if I had 4 divided by 4, that equals 1. And then I have to do the same with the denominator. I have to find the factor that goes into 20 as well, which we said was 4. So 20 divided by 4 equals 5. And we can then say that 4/20 is the same as 1/5. 1/5 is the fraction in its simplest form. So let's just go back and remind ourselves of the calculation that we've done. 1/4 times 4/5 equals 4/20. 4/20 equals 1/5. What I'd like you to do now, please, is to go on to the next page, and there are a number of questions. I'll zoom into these questions so that you can see them a little bit more clearly. So I just go to view and full screen. We should be able to see them a little bit more clearly. I would like you to press pause on your video now and have a go at them, and I'll come back in around about 2 or 3 minutes. Okay, so here are the answers. I'll just zoom in once again so that you can see them really clearly. There we go, and just have a moment to press pause and then just mark them. Remember that here we've got the answer and then it's in its simplest form. I'll zoom out now so I can get the camera back, press pause, and we'll go on to the next. So today we're on our second lesson of position and movement, and we have Elliot here who says, can we describe the position of each point using coordinates? Unfortunately, Elliot hasn't yet put in the coordinate line, so I'm going to use my ruler here to then put a coordinate line, the y-axis through there, and I'm going to put the x-axis through here like so. Now have a look and see whether you can work out what the points A to E are on the coordinate grid. Press pause, have 5 minutes or so to try and work that out. So Elliot's had a go at putting the coordinate grid through D representing 0 and 0. So I'm going to start now with the letter C here. So C, we've got to work out, first of all, how far across C is, or how far along the x-axis. I like to think that we always do x first before y, and x comes before the y in the alphabet. Lower down in the school, you might have said along the corridor before you go up and down the stairs. So C is 2 steps along the x-axis, and we can see that that's what Elliot's written in here, and then it is 1, 2, 3 steps up the y-axis. So the coordinate is written as 2, 3. Remember to put a comma in between the 2 and the 3 and brackets outside of the coordinate itself. We then go to the coordinate A, which is here. Now we always go along the x-axis first, and this time we're going -1 because A is -1, or a step of -1, and then it is at 6, and Elliot has written that in -1 and then 6 and written it into the coordinate grid there. Then we've got B. Well, Elliot's already written the x-axis coordinate for B as 1, 2, 3, 4. And we've got to work out how far up the y-axis it is. And it goes all the way up to the point 6. So in here we will have the number 6. And then E is 5 steps along the x-axis, which we can write in here. Elliot's all written that it's up 1 step, so he's written that already in there. Okay, now interestingly, Emma, whose name I've forgotten, and I had to ask Tom from year 5 to email me the names of all the children from That's No Problem. Unfortunately, there's no Olivia in front of me now to remind me of the names. But Emma, anyway, has put the coordinate grid through B, where B is 0, 0, and then asked us to work out the coordinates of the other letters. Just have 2 minutes now to see whether you can work out what the coordinates are. So the first one she looks at is D. And if you look closely, we go along the x-axis again to -4 and then down to -6. So the coordinate is -4, -6. But if we have a look at E, we'll see that E is 1 step along, so it's 1, and then -5 down. So the coordinate is 1, -5. Out of interest, C is -2, -3, and A is -5, 0. What I'd like you to do now is to have a go at the guided practice. And it asks you to write the coordinates of point 3, point A, point C, and point K. And then point M is such that triangle MAC is an isosceles triangle. Write the possible coordinates of point M. So if I zoom in again, just to make it full screen so that we're able to see, you've got to work out point M has got to come somewhere linked with these 2 points here to make an isosceles triangle. Remember, an isosceles triangle is one with 2 sides of the same length. Press pause on your video now and then have a go at those questions, please. Okay, so here are the answers. They're fairly easy to look through, but I'm just going to go through this answer here. It says point M is that triangle MAC is an isosceles triangle, and the answers may vary. Now I know that this side is 1, 2, 3, 4, 5 squares long, so I could have another side that is 5 squares too. So let's draw in a line here that is 5 squares along. So if I went 1, 2, 3, 4, 5, I will now have an isosceles triangle. So I could have one of the answers of M being this point here, being 0, 0, because then that would create the isosceles triangle here, where this triangle, this side, sorry, and this one is equal in length. But there are other ways that you could have an answer for that. If I just press the undo button, we'll be able to see some other places. Now, one thing you could do is to have this side as the one that's not the equal length, but the 2 here. So you could have, in effect, the sides from A to M, M being here, and C to M being the same length. So we've got this side and this side are equal lengths. And that could be all the way up here. We would have an isosceles triangle apart from 1, 2, 3, 4, 5, whereby this length here would be 5. So you could have point M being 2.5 along and then -2, or 2.5 -1, or 2.50, or 2.51. So your answer could vary for that along that line on the x-axis here. So if I just press undo and make that clearer, the line would be along 2.5 here, and you could have a coordinate anywhere along here. Okay, so let's go on to the next slide. This is our workbook activity. Unfortunately, I couldn't give you the 2 pages of the workbook because one of them required you to draw on the workbook itself, and we can't do that. But you can have a go at this question here. So just spend 2 or 3 minutes now having a go. What are the coordinates of all of these points? And then point E is that quadrilateral ABED, this shape here is a square. What would be the coordinate of point E? Have a go. Okay, and here are the answers. You can check those. If you want to look at this one again, you'll have to go back in the video and just to see where this point would be. I can't fit both of them onto the screen today. Okay, that's the end of today's lesson. I hope again it's been useful, and I'll be back with another lesson on Friday. Bye for now.